Welcome to the Deep Dive. Today we're going to get into something pretty fascinating. Artificial intelligence and robotics.
Hmm.
And maybe forget the usual sci-fi stuff for a bit, because these technologies, well, they're raising some really interesting, genuine questions about how we live, how we interact with the world. We've pulled together quite a range of material for this one. Some really thoughtful, philosophical angles, insights from the people actually building this tech, the computer scientists, and also a feel for what the public conversation is like right now.
Yeah, and our goal here really is to cut through some of the noise, maybe the hype, and get to the heart of what's genuinely worth thinking about as AI and robotics get more sophisticated. We want you to come away with a solid handle on the key debates, the challenges, without feeling like you need an engineering background to sort of keep up.
Okay, so whenever there's a big new technology, people tend to get, concerned, right? Sometimes looking back, it's kind of funny, like people worrying trains are too fast for the human soul or something.
Right.
But other times, those concerns are spot on. Think about how cars changed landscapes, or the internet changed,
Yeah.
well, almost everything. So with AI and robots, how do we sort of sift through that, figure what's a real ethical head-scratcher versus maybe just initial jitters?
That is the crucial first step, I think. So often, the media coverage, it jumps to big predictions, risks way down the line. And that can actually distract us from the ethical questions we need to grapple with now, the situations where it's genuinely unclear what the right thing to do is.
Oh, okay.
So it's important to distinguish between, say, a technical problem like automation affecting jobs, which is huge, don't get me wrong, a massive societal issue, and the more fundamental ethical questions, like, is it permissible to deploy systems that might lead to those outcomes?
Right. And what about companies talking about ethical AI? Is that meaningful?
Well, that's where you get into the risk of ethics washing, using the language of ethics for PR, versus actually implementing legally binding regulations and accountability that might challenge how things are currently done, challenge existing power structures. The focus really needs to be on the how. How are principles actually put into practice and checked?
Got it. So it's less about speculating if a robot will suddenly wake up,
Huh. Yeah, maybe less about the Terminator scenario for now.
and more about how we're designing and using the AI and robots we actually have right here, right now.
Precisely. Our focus today really is on the ethical issues that come up from using these autonomous and semi-autonomous systems. But, and this is important, we also have to think about responsible design just as much as responsible use. Because the way you build the tech fundamentally shapes how it gets used later on.
That makes a lot of sense. I mean, if you design a tool primarily for surveillance, it's probably going to be used for surveillance. And speaking of watching, data ethics seems like a massive piece of this AI puzzle.
Oh, absolutely. Data privacy was already a big deal, in the digital age. But AI it cranks things up a notch. Think about face recognition. Suddenly you can identify people almost anywhere, from images, videos. And then there's something called device fingerprinting. This is where systems analyze all sorts of little signals your device sends out: browser type, plugins, screen resolution, fonts, and they piece together a unique profile, like a digital fingerprint. It paints the surprisingly detailed picture of an individual, often from seemingly unrelated bits of data.
Wow, so it's like we're leaving these invisible trails everywhere online.
Pretty much.
But it's not just collecting it, is it? The really tricky part seems to be what happens with that data.
Exactly. The big ethical questions really surface around how that information gets used, particularly when it's used to influence our behavior, online or even offline. We're constantly interacting with systems that know quite a lot about us, which makes us potentially vulnerable to these subtle pushes, sometimes called nudges. Yeah, the idea is they're supposed to gently guide your choices in a helpful direction, and they should be easy to ignore. But there's a real concern about the slippery slope, When does a helpful nudge become manipulation? Or even a kind of paternalism where the system decides what's best for you.
It definitely feels like every website, every app is trying to nudge you towards something. Makes you wonder how much is genuinely your choice.
It's a very valid point. And the EU's GDPR, the Big Data Protection Law, tries to address some of this. It includes what they call a right to explanation for decisions made by automated systems.
Ah. So you can ask why an algorithm decided something about you.
That's the idea. But how effective that right is, how detailed the explanation needs to be, whether it's truly enforceable, that's still really being debated. Some also argue there's a double standard. We don't always demand that level of explanation from human decision makers.
Interesting point. Okay, let's shift gears a bit. Another huge topic is bias in AI systems. What are the real-world effects we're seeing?
Right. So AI decision support systems, they operate on data, they take data in, analyze it, and produce outputs that can have really significant consequences. Think loan applications, healthcare diagnoses, even things like parole decisions or where police patrol.
Okay.
The major concern is that if the data these systems learn from reflects existing societal biases, racial bias, gender bias, whatever it might be, then the AI doesn't just replicate those biases, it can actually amplify them.
Amplify them. How?
Well, take the example of predictive policing. Let's say historical crime data shows more arrests in a particular neighborhood, maybe due to biased policing patterns in the past, not necessarily more actual crime. An AI trained on that data might then predict a higher likelihood of crime in that area.
Leading to more police patrols there.
Exactly, which statistically often leads to more minor offenses being discovered and recorded in that specific area.
So it becomes a feedback loop,
Right.
reinforcing the original bias.
Precisely. It's a serious risk. And it highlights that the challenge isn't just, cleaning bias out of the AI itself. It forces us to confront the biases baked into our data, our institutions, our society. The AI is kind of holding up a mirror.
So these systems aren't necessarily predicting future criminal masterminds then?
Generally, no. That's often a misconception. Current predictive policing is usually more about allocating resources, deciding where patrols might be needed based on past patterns rather than trying to foresee specific future crimes somebody's planning.
Right, that's an important distinction. Okay, let's think about a completely different application. Care robots. Robots designed to help people, maybe provide companionship. What are the ethical considerations there?
Yeah, care robots are definitely an evolving area. You have everything from quite functional devices that help human caregivers with, say, lifting patients,
Right.
to robots like Parallel, the fluffy seal robot, which is really designed for emotional comfort and companionship, particularly in elder care or dementia care.
It's a seal robot, right? I've seen pictures of that.
One of the main arguments driving their development is the idea that, with aging populations in many countries, we're going to face increased care needs and maybe shortages of human caregivers. So robots could fill a gap.
Seems logical on the surface.
It does, but it rests on a couple of assumptions that are worth poking at. Like, does living longer automatically mean needing more intensive care? And is it really inevitable that we won't be able to attract enough humans to caregiving roles? Maybe the issue is how we value and support those roles.
So it's not a foregone conclusion that robots are the only answer, or even the best one?
Not necessarily, or at least not in the way it's sometimes framed as a simple replacement. Automation could potentially enhance care, maybe by freeing up human caregivers from routine tasks to focus more on the uniquely human aspects, the empathy, the conversation, the connection.
Oh, okay.
And that really gets to the core ethical distinction, the difference between a robot performing a care task, like bringing medication, and providing genuine, intentional care, the emotional component.
To feel it.
Exactly. There's a definite risk that if we rely too heavily on robots, we might see a reduction in that essential human interaction, that intentional presence.
Which seems so crucial in care settings.
It does. Interestingly, though, some research suggests that even interacting with or caring for simpler virtual agents can have positive psychological benefits for the human doing the interacting.
Really?
Yeah. But this raises its own ethical question. Is it okay for robots to simulate caring, to appear to have emotions they don't possess? Probably only if there's a clear, significant benefit to the human involved, and perhaps if there's transparency about it. Deception is usually ethically problematic.
Right. That feeling of connection is just so fundamental. Hard to imagine a machine truly replicating it.
No.
Okay, switching gears again. Let's talk autonomous vehicles. Self-driving cars. Big promises of safety, but also some thorny issues, yeah?
Definitely thorny. Autonomous vehicles, or AVs, hold enormous potential, especially for reducing the harm caused by human driving errors, fatalities, injuries, maybe even environmental impact through more efficient driving.
That's the big sell, isn't it? Fewer accidents.
It is, but they also bring up really tricky questions about how they should be programmed to behave, especially in situations where an accident might be unavoidable. And then who's responsible when something does go wrong? It's such a complex system.
This is where we always hear about the trolley problems, right? The car has to choose between, say, hitting pedestrians or swerving and harming the passenger. How relevant are those scenarios, really?
They get a ton of media attention, those trolley problems, and they're interesting thought experiments, for sure. They were originally designed in philosophy to probe our intuitions about ethics, especially the difference between actively doing harm versus allowing harm to happen.
Right.
But their direct application to programming AVs is Well, pretty doubtful, frankly. Real-world driving is incredibly complex, dynamic, full of uncertainty. It's not usually a binary choice between two clearly defined bad outcomes presented instantaneously.
So it's more nuanced than just swerve left or swerve right.
Much more. There are constant micro-decisions, probabilities, reaction times. While trolley problems spark discussion, they don't offer many practical answers for engineers building these systems. The ethical debates in AVs are often more about risk assessment, data standards, testing safety.
And setting up clear rules and regulations.
Exactly. And we're already seeing different approaches there. You have places like Germany and the EU being generally more restrictive about licensing and testing AVs on public roads, compared to, say, the US, where there's arguably been more of a tested on consumers approach, sometimes without explicit, fully informed consent about the risks involved.
Right. Different philosophies on rollout. Okay,
Yep.
now a really heavy topic, one that sparks intense debate. Autonomous weapons.
Yeah.
Lethal autonomous weapon systems or laws.
Yeah, this is critical. The idea isn't brand new. Discussions about sophisticated reconnaissance and attack vehicles have been around, but the core concern now is about systems that can independently identify, select, and engage targets without direct human intervention for that final decision.
And the worry is,
A major worry is that removing the human from that final kill decision could lower the barrier to using lethal force. It might make going to war seem easier, less costly in terms of immediate human risk for the deploying side. And it significantly complicates accountability. We already see some challenges with remotely controlled drones, the distance it creates. Now imagine small, maybe swarming, autonomous drones programmed to target specific individuals or even just types of individuals based on certain characteristics. Groups like the Campaign to Stop Killer Robots are raising serious alarms about this.
the thought of a machine making that ultimate decision is, deeply unsettling for a lot of people. What about accountability? Who's responsible if an autonomous weapon makes a mistake, hits the wrong target, causes civilian casualties?
That is a central, maybe the central problem. It's often called the accountability gap or sometimes the retribution gap. With complex autonomous systems, it could become incredibly difficult to pinpoint who, if anyone, should be held legally or morally responsible for unintended harm.
So no one is to blame.
Well, it's complicated. Interestingly, in some ways, the digital nature of these systems might actually create better records of what happened in conventional warfare compared to purely human actions. But assigning responsibility is tough. A lot of the current discussion revolves around maintaining meaningful human control. You hear phrases like keeping the human in the loop or on the loop.
What's the difference there?
Generally, in the loop means a human has to actively approve each target engagement. On the loop suggests a human is supervising and can intervene or override the system, but the system might act autonomously otherwise.
But how much control is truly meaningful? Seems fuzzy.
It is fuzzy, and that's part of the debate. Perhaps a more useful way to frame the issue isn't just about assigning blame after something goes wrong, but about the distribution of risk beforehand. Who is being put at risk by these weapons? Who stands to benefit? And crucially, who gets to make the decisions about their development and deployment?
So shifting from individual fault to looking at the whole system of how risk and responsibility are spread out.
Exactly. We have established ways, however imperfect, of distributing responsibility in other complex technological systems, like car manufacturing, aviation, pharmaceuticals. We need to figure out how that applies, or it needs to be adapted, for AI and autonomous weapons. Some talk about distributed agency in AI systems leading to a need for distributed responsibility.
Okay. Thinking about all these advanced capabilities, even if hypothetical for now, it almost inevitably leads to the question, should robots have rights? Sounds like pure sci-fi, but people are discussing it seriously.
They are. It's a real debate. Some arguments for robot rights often start by criticizing the arguments against them, or by observing that we sometimes already treat robots, even simple ones, as if they have some kind of standing. People getting attached to their Roombas.
Naming them.
Exactly. There's a proposal called the relational turn, which suggests we should focus less on whether robots really have consciousness or feelings in a human sense, and more on how we relate to them, how we treat them. It's a human-centered approach to the question.
Interesting angle. But not everyone agrees.
Oh, definitely not. Many philosophers and ethicists argue strongly that robots, as artifacts, should not have rights comparable to humans or even animals. And there are deep ethical doubts about the whole project of trying to create robots that could potentially qualify for rights, or become what philosophers call artificial moral patience beings towards whom we have moral obligations.
Why the doubts?
Well, if you take the possibility of artificial consciousness seriously, even within the research community, there's a growing concern about the ethical obligations we might suddenly find ourselves facing if we succeed. If we create genuinely sentient beings, would we then have duties not to harm them, not to deactivate them, perhaps even to provide for their well-being? It's uncharted territory.
Right. That could get very complicated very quickly.
It could. And it's led some researchers in artificial consciousness to call for what they term a moratorium on synthetic phenomenology. Basically, let's pause research explicitly aimed at creating subjective experience in machines until we've thought through the ethical consequences much more carefully.
Wow. Okay, so that's the should we question. Let's talk about the how. How do you actually go about programming ethics into a machine? It sounds incredibly difficult.
It is fundamentally difficult, not just technically, but conceptually. There are some core challenges.
Like what?
Well, first, for many ethical rules to apply, especially those concerning how we treat humans, a machine needs to be able to reliably distinguish humans from non-humans. This sounds simple, but it bumps up against things like the unresolved Turing test, the challenge of deception. How do you create a computational ethical dignity test that can't be fooled?
Good point. What else?
Another huge one is dealing with consequences. Our actions ripple outwards in complex ways, often far into the future. Where do you draw the line for what a machine should consider? It seems arbitrary. And this contrasts with a lot of classical human ethics, which often puts a heavy emphasis on intentions, not just outcomes.
Right. But how on earth do you program an intention into a machine? You're getting into really deep philosophical waters there. Volition, free will, subjectivity.
Exactly. These are concepts we still grapple with understanding in ourselves, let alone programming them into silicon. So trying to hard code a comprehensive set of ethical rules seems, well, maybe impossible, or at least fraught with peril.
So if direct programming is so hard, what about machine learning? Can we teach machines ethics by showing them examples, letting them learn from data?
That's the other main approach being explored. Machine learning works differently from classical programming, where you give explicit step-by-step instructions. With machine learning, especially methods like deep learning, the machine learns patterns and relationships from vast amounts of data. Think about how AI learned to play chess or Go's, not by being given rules of strategy, but by analyzing millions of games.
Okay.
One technique relevant here is learning by imitation. The machine observes agents considered good at a task, say expert human drivers, or maybe people making ethical judgments in surveys, and it learns to mimic their behavior statistically. It doesn't necessarily understand the goal or the principles behind the behavior, just the patterns.
So you could survey lots of people on how they'd react in different ethical dilemmas, feed that into an AI for, say, an autonomous car.
That's the idea some researchers have explored, yeah. Collect human responses to various scenarios, extract the statistical patterns, and hope that gives the AI a kind of moral compass based on collective human judgment.
But that sounds like it could have problems too.
Oh, absolutely. Big problems. One is explainability, or rather, the lack thereof. Machine learning models, especially complex ones, can be like black boxes. They might arrive at an effective decision or pattern, but they often can't explain why.
And for ethical decisions, the why seems pretty important.
Crucial, I'd say. We need to be able to understand, scrutinize, and justify ethically charged decisions. If the AI just says, the algorithm made me do it based on patterns in the data, that's often not good enough.
And the other problem, you mentioned bias earlier.
Exactly. Bias is the other huge issue. If the population you survey to get your ethical data holds the biases, and we know human populations do, then the AI learning from that data will simply learn and replicate those biases. You end up with an AI that reflects, say, the majority's prejudices. And as the saying goes, good and evil is not determined by what the majority says. Ethics isn't just about imitation or popularity. It requires reasoning, justification, maybe something like goodwill.
Right. Just copying the average response doesn't make it ethical. So machine learning isn't a silver bullet either. What about game theory? Can that help machines make moral choices?
Game theory offers another lens. It's a mathematical framework for analyzing strategic interactions between rational decision makers. It's used a lot in economics and computer science. But standard game theory often assumes self-interest as the primary motivator, so to use it for moral decision making, you need to modify it, extend it.
How do you do that?
Well, you can incorporate ethical considerations into the models. For example, instead of just maximizing your own payoff, maybe an AI is programmed to ensure a certain minimum outcome for other agents involved, a kind of fairness constraint. Or perhaps it incorporates principles of cooperation or reciprocity.
So building ethical rules into the game structure.
Sort of, yes. But game theory also has limitations in capturing the full richness of moral dilemmas. For instance, remember the distinction between doing harm and allowing harm we touched on with trolley problems. Standard game theory might treat two choices with the same outcomes as strategically identical, even if one involves active intervention and the other is passive. Our moral intuitions often differentiate, though.
So it misses some nuances.
It can. Researchers are exploring ways around this, like maybe formally labeling an action as passive or incorporating concepts like what agents deserve based on some theory of justice or desert. There's also the issue of framing effects, how the way a problem is presented can change human moral judgments, even if the underlying facts are the same. Should a moral AI replicate these human inconsistencies or be purely rational and consistent?
That's a tough one.
It is. People are also looking into quantitative ways to assess moral wrongness or using probabilistic frameworks to handle uncertainty. The potential is there, perhaps, for game theory and machine learning to complement each other in developing more ethically sophisticated AI. Neither seems sufficient on its own.
It really sounds like there's no single easy answer to embedding ethics in AI. It touches on so many deep issues. Finally, let's bring this into a specific critical domain. Healthcare. AI is increasingly used there, right?
Absolutely. AI is finding its way into many aspects of life, but its use in critical areas like healthcare for things like analyzing medical images, assisting in diagnosis, even guiding robotic surgery raises particularly pointed ethical questions.
Which has led to this field of AI bioethics.
Yes, exactly. It's this emerging area where we as humans are grappling with our ethical relationship towards these powerful artificial tools, our own creations, especially when they impact life and health. It forces us to confront those fundamental questions again. Can machines have minds, consciousness, sentience? Can they truly intend harm or just cause it as a result of their programming or data? And again, should they have rights or moral standing?
And the bias issue must be especially critical in healthcare.
Extremely critical. AI systems can absolutely reflect and perpetuate human prejudices present in medical data biases related to race, gender, socioeconomic status. This can lead to disparities in diagnoses, treatment recommendations, access to care. Recognizing and actively mitigating these biases is paramount.
Are there guidelines emerging for this?
Yes. For example, the European Union has put forth ethics guidelines for trustworthy AI, emphasizing principles like accountability, transparency, or explainability, and ensuring systems are unbiased and fair. There's a strong emphasis on the accountability of the humans involved, the designers, developers, deployers, for the outcomes and impacts of the AI they create and use.
It seems like a constant theme. The responsibility always comes back to the humans.
Ultimately, yes. Because while AI is becoming incredibly capable in certain tasks, it lacks genuine empathy, understanding, wisdom, those uniquely human qualities. Joseph Weizenbaum, an early AI pioneer who became quite critical of the field, warned decades ago against delegating crucial human decisions to computers precisely because they lack these qualities. They can calculate, but they can't understand in a human way.
So AI remains a tool.
A very powerful tool, but yes, a tool without authentic feelings, without the capacity to truly commiserate or exercise wisdom born from lived experience. And that necessitates extreme caution in how we develop and deploy it, especially in sensitive areas like healthcare. The EU's white paper on AI also stresses this cautious approach.
So just to kind of wrap things up here, we've really journeyed through a complex landscape, from the basic challenge of even defining what ethical behavior means for a machine.
Right, all the way to specific flashpoints like surveillance, bias in decision-making, the nuances of care robots, the dilemmas of autonomous vehicles, and the profound questions around autonomous weapons.
And we've touched on how hard it is to actually implement ethics, whether through direct programming, machine learning, or game theory, and the pitfalls of each approach.
And hopefully it's become clear that these aren't just technical puzzles to be solved by clever coding. They're deeply intertwined with philosophy, with our understanding of human nature, intention, responsibility, and moral judgment itself.
Which leads us perfectly into our final thought for you to take away today. As we continue this effort, this grappling with how to embed ethics into artificial intelligence, what does this whole endeavor reveal about our own understanding of morality? Is being good simply about following a complex set of rules, something we could potentially program? Or is there something more fundamentally human involved, perhaps empathy, wisdom, creativity, our capacity for subjective experience that might always remain beyond the grasp of pure computation? It's a question that really invites us to think about the intricate, evolving relationship between the powerful technologies we create and the deepest ethical values that define us as human. Thanks for joining us for this deep dive.